Okay, so we're not going to prove all of these identities, but what we're going to do is we're going to state that all the identities that we gave you before, which we did give reasoning for, all the identities with the integers are going to hold in the situation where we have rational exponents as well. So this means so long as all of these things are defined, so if they exist, because maybe some of these don't, because of negatives and roots and so on, we'll have a to the r times a to the s is a to the r plus s. A to the r to the s equals a to the rs. These were the two rules we originally wanted to make hold when we were choosing what to allow a to the 1/2 to be. A b to the r is going to be a to the r b to the r. And then for division, just like we had before, also a over b to the r as a to the r over b to the r. And then finally for negatives, which we already have used, so all the rules we had before all still hold. We do need that if all these expressions exist, because maybe we're in some sort of a situation where a is 0 and we're taking 0 over 4 to the minus r, and we can't take anything over 0 or anything like that. So we're assuming these expressions individually all exist, and we have these rules. Okay, so let's look at some examples. Let's start off kind of simple. Let's say we have something like, I don't know, 8 to the 7/3. Okay, so using my rules, what I could do is I could take 8 to the 7 to the 1/3. And that would require me to immediately compute 8 to the 7th power, which I could do. It probably would help me to have a calculator, or maybe not. Maybe I could just know that 8 is 2 cubed and use some trick with the 3 times 7. I could do that as well. But this might not be the easiest way to do the problem. I could also do 8 to the 1/3 to the 7th. I get to choose because of my rule for products. My rule right here. A to the r to the s is a to the rs. So since I have 7 times 1/3, I could either treat this as a 7 here and a 1/3 here, or a 1/3 here and a 7 here. So which of these is probably easier? I think most of you will find this easier. 8 to the 1/3 is the cube root of 8, so I get 2 to the 7th power, which happens to be 128. Either by calculator, or by doubling in your head, or by knowing a little computer science. 2 to the 8 comes up a lot and is 256. Lots of ways to get there, but that's one. I could have computed 8 to the 7 as well. That's fine as well. If you prefer doing that, that's okay. Each of these methods is going to get you to the same result. But just remember that you're in control here. If you want to take the root first, you can take the root first and make the number smaller before taking the power. Something that students forget a lot in my observation.